So here we're taking a look at the 4.4 material, working primarily with the slope of a line. This is an absolutely critical section when we are working with, and what we'll eventually get to, which is creating and solving for linear equations. So we have our main definition or definitions of the slope. We generally denote it using the variable m in our equations that we're going to use. And our general equations, to more specific ones, is the rise of a line over the run over line. We also refer to it as the change in y over the change in x. And more explicitly, y2 minus y1 over x2 minus x1. And we're going to get into using this form quite a bit, our stuff here today. All three of these forms of the slope of a line have their uses. Do not dismiss them just because, well, we probably use this one more often than not. That's very true. You still want to know the change in y over the change in x, and the idea of it being the rise over the run of a line. So again, all of these are accurate. We will be using all of them, and they have their uses. If we are going to be calculating the slope, which is what we're going to go through and do currently, we are going to need 2 points. We will always need 2 points to go through and make this happen. Whether we're doing it graphically, which we'll go through and do, I'll bring that up so you guys can see what that is going to look like. Again, I'll go to I can speak properly. We will go to GeoGebra for that one, and I'll just put in an equation, and then we'll solve for that accordingly. Here. So we have our methods for doing this thing graphically and finding that value. We also have methods to go through and find this thing algebraically. So going through and finding it graphically, that's where we're going to be using our two versions of this, the rise over the run, or the change in y over the change in x. And then algebraically is we're going to go through and actually algebraically solve this thing with our final form that we have. But again, in either instances, we need 2 points. Okay. So let's go through, and we'll go through our process to go through graphically, and we'll go through algebraically shortly after. And we'll use some examples for each of these as well. So graphically, we have been given a graph to make this happen for ourselves. We're plotting, it could be the case that we're plotting 2 points. It could be the case we have been given a graph. Plot 2 points given a set of axes. And it could be the case, again, we are identifying 2 points on a set of axes and a line that we have been given. So this could be plot, this could be determine, either way. We need 2 points. Create a triangle between them and determine the rise and the run from one point to the other. The sign and the direction absolutely does matter in this step. And we'll go through and I'll show you guys what this is going to look like here in a minute. We're then going to plug these values into the equation for the slope of m is equal to rise over run, or the change in y over the change in x. It does not matter which one you choose. You need to pick one and move forward with it. Once we have those values plugged in, then we just simplify the fraction that's been created, and we have our slope. Okay. So I'm going to go through and jump us over to GeoGebra. I'll show you guys what this is going to look like graphically. So this is the home page for GeoGebra here. We're going to go into calculator. And apparently now it's going to have to load. Okay, there we go. So I'm going to set this thing up for showing these. I just want the major grid lines. We don't need the extra stuff in there. So I'm going to create an equation here. And let's go with one of, let's say y equals 2x minus 4, because why not? Okay. So what we need to do as we went through and we're solving for this thing graphically, I need to find 2 points on this graph. It does not matter which 2 points I choose. I just need to choose 2 of them, and then I can move forward with this. So I'm going to zoom us in here a little bit. So we have our 2 points here. So I'm going to choose arbitrarily to use a point we have right here. It's a clearly defined point, and our point that we have right here. So I'm going to, let's see if this program will let me do this. Yeah, it will. Fantastic. So I'm going to choose the point. You can do this graphically or when you're drawing this on your paper. I'm going to choose a point right here and a point right here. So now, based on our process, we were told create a triangle between them and determine the rise and the run from one point to another. Okay, so making a triangle with that. So we could go in and, where is my point in here? So I'm just going to create some segments with this. So how far am I moving horizontally with this? Well, I'm starting here and I'm moving to here. So suddenly now I'm at, oops, if I can get rid of, I don't want that. What's this doing to me? Okay. Let me clear all this. A little bit more of a pain than it needed to be. Okay, so what was our equation? Y equals 2x minus 4. All right, so because this thing is being a pain, I guess I'll try and draw this thing in. See if it's going to cooperate with me. Okay, so we had a point set up for ourselves. I'll do this in red so it stands out. A point set up for ourselves right here, and a point set up for ourselves right here. Now again, we want to see how far horizontally and how far vertically are we moving to get from one point to another. So horizontally, we're moving there. Vertically, we are moving there. Now, I've set up my triangle this way. You could just as easily set up your triangle that way as well. Does not matter. You just got to pick one and move forward with it. So here, now we're going to ask ourselves, okay, how far am I moving horizontally, left to right? And I'm only moving one place. Specifically, I am moving one in the positive direction. Got a positive 1 there. How far am I moving vertically? Well, I'm moving up 1, 2 spaces, and I'm moving in the positive direction. So I've got 2 written in there. Our process told us now that we have our change in y and our change in x, we're going to write that into our equation and solve accordingly. So our change in y values for our change in our x values. We use delta to represent change. That's what that triangle is. So what is our change in y? We're increasing by 2, positive. And what's our change in x? Let's say 1. So what is our slope to this thing? It's going to be 2. And we have our answer. So again, this is pretty much how we're going to be going about doing this graphically, or how I'd recommend you go about doing it graphically. Remember, the value of how many places we're changing is important. And the direction matters as well. Am I moving up? Am I moving down? That will determine if one or both of these changes is going to be positive or negative. We absolutely need to keep track of that for ourselves. Again, this is where I think making a visual goes along and helps with this quite a lot. So I'd recommend doing this for yourself if you need to solve these things. So this is going through and solving for this or finding that slope if we're going to go through and do it graphically. There's not a whole lot of variability that we can do with this other than, again, make the triangle, calculate each of those numbers, plug it into our equation, and then just reduce it down from there. And we will, and you should expect to get full-blown fraction answers to the slope of a line. It's very, very common for that to occur. But once again, just make sure that your fraction is fully reduced and you're good to go. There's nothing wrong with fraction answers. So I'm going to jump us back to our notes, and we're going to take a look at how we would go through and solve this thing algebraically, because this is the more common occurrence that shows up. So algebraically, and we could do this if we had a graph with some points also, but this is the more in-depth way. We've got some examples down here. Identify and label 2 points. Again, we're finding the slope, and it hasn't been given to us, we absolutely must have 2 points to do that. So I have to give those to you either explicitly or give you a graph so you can find those 2 points on your own. You'll need to label each of those points. One of them is going to be x sub 1, y sub 1. The other is going to be x sub 2, y sub 2. It does not matter which one you label as which, but label them each accordingly before we get going on and moving forward in this process. Second step, plug the corresponding values into the equation for the slope. M equals y2 minus y1 over x2 minus x1. And once again, it does not matter which one is y2, y1, or x1, y1, x2, y2. You just need to label one point of each of those accordingly and then plug it into here. You will get the exact same answer no matter how you label them. When you are substituting values in, put the number and the signs inside of parentheses. A lot of people do not do this, and especially when we have negatives showing up, as we'll see in a couple examples down here, it absolutely messes with people's problems that they have. They get wrong answers from there. After we have everything plugged in, then we're just simplifying. Simplify the numerator, simplify the denominator. Can I reduce the fraction? We go from there. So we're going to go through a couple examples down here where we are asked to calculate the given slope based on what we are working with, and then leave our answer as fully reduced fractions. So we're going to go into this and over on our whiteboard and go from there. Okay, let me separate these out. Oops. Okay, so we have, for our first example, we're asking to calculate slope. So our first example, we have been given the points 2, 3 and 4, 6. So again, we have 2 points. We need to label them x sub 1, y sub 1, and x sub 2, y sub 2. It does not matter which point you label to be x sub 1, y sub 1, x sub 2, y sub 2. You will get the exact same answer regardless of whether you have them, you use the same method that I'm going to use, or you reverse them. You will get the same answer either way. You just need to pick one and move forward with it. I'm hoping that's a kind of a common theme you guys are seeing with a lot of the stuff with math. Lots of options, pick one and move forward with it. So I am going to choose to label, my first point here is x sub 1, y sub 1, x sub 2, y sub 2. Just like we have that there. Now I'm going to write up my general equation for the slope that I'm using, which is y2 minus y1 over x2 minus x1. This equation that we have right here, this needs to be written in this form. That's where we have no exceptions or no wiggle room on. Which of these points is x1, y1, and which one is x2, y2? That's where we have our flexibility. Okay? So now that we have each of our values labeled, the guesswork has been taken out of it for us. Y sub 2, well, that's going to be 6, minus y sub 1, which is 3, over x sub 2, which is 4, minus x sub 1, which is 2. So I have everything plugged in, and now I can simplify this thing. Simplify the numerator, 6 minus 3, that's going to give me 3. Simplify the denominator, 4 minus 2, that's going to give me 2. I cannot reduce this fraction down, so I have a slope of 3 over 2. My rise is 3, my run is 2. The change in y is 3, the change in x is 2. So we can think of all of those, the slope and any of that, as kind of the steepness of our graph overall. Is it a very steep graph? Is it a not very steep? Is it increasing as I move left to right? My value is getting larger. Or is it decreasing as I move left to right? And my numbers are getting smaller. So there are different meanings that we have of the slope because they're very, very important. Oops. Okay. So our second example, we're given the points -4, -1, and 6, 4. I'm told to calculate the slope of this thing. So again, we're choosing which one's going to be x sub 1, y sub 1, x sub 2, y sub 2. Okay. So as we're going through this, again, we're going to label, here's our first value. Oops, this thing will, there we go. Label your 2 points. Which one is x1, y1? Which one is x2, y2? First thing you're doing. So again, now that we have that labeled, we're starting with our general equation for the slope. So that's y sub 2 minus y sub 1, or x sub 2 minus x sub 1. So again, just like we did with our first example, I am now plugging in what I have labeled in my problem into this equation accordingly. So where y2 is, I'm going to put in 4. Where y1 is, I'm putting in -1. Where x sub 2 is, I'm putting in 6. And where x sub 1 is, I'm putting in -4. So I'm just substituting this step. A lot of people rush this step in their process, and lots of people make lots of errors because of this. So again, when you're substituting things in, do it inside of parentheses, because right here is where people make mistakes. They see, okay, y sub 2 minus y sub 1. Well, y sub 1 is -1. Well, it's already a negative, so I can just put in -1 in there. And that right there is where you're going to lose points. We need to plug in each of those values that we have been given inside of parentheses. The value and the sign is absolutely critical that you do that. If you don't, you're going to lose points, you're going to get wrong answers, and everything's going to spiral out of control and just fall apart with this problem. So our x sub 2, oops, so 6 we have, minus -4. Again, it's all just coming right from how we labeled our values up top. It's a better x here. Better x sub 2. There we go. So again, as you're going through these things, especially if you have negatives showing up in here, make sure every single part lines up. Y sub 2 is 4. It's 4 just like I have it labeled up here. So 4, y sub 2, y sub 2. -1 is y sub 1, just like I have it up here. Okay, so that checks out. 6 is x sub 2, right, like we have up here. -1 is x sub, or -4 is x sub 1, just like I have right up here. So everything should fall in line just like we have it labeled. And then now from here, now I'm simplifying the numerator, and then I'm simplifying the denominator. So in my numerator, I have 4 minus -1. I've got double signs in there. I don't like that. I'm going to change that before I do anything else. So that's going to become 4 plus 1. Same thing with the denominator. I have 6 minus -4. Negative and a negative is going to make a positive here, because we don't like those double signs showing up. Now we combine everything in the numerator together. 4 plus 1 is going to give me 5. Everything in the denominator, 6 plus 4 is going to give me 10. So I get m is equal to 5 over 10. Whenever we have fractions, we always, always, always need to simplify and reduce them down. So I can reduce 5 over 10 down to 1/2. Numerator and the denominator can both be divided by 5. So fully reduced, our slope is 1/2. We're rising 1 going over 2. The change in y is 1 over the change in x of 2. Okay. So again, biggest part, and we'll go through 2 more examples with this, but I do want it to hit home of if you do not label these points, I think the rest of the problem becomes significantly more difficult at that point in time. I have seen many a time people will get, okay, this is a 4, I'm putting it right here. This is a -1, I'm putting here. And then I'll put this -4 right there, and then I'll put that 6 right there. People are just arbitrarily throwing numbers around and putting them somewhere in this entire equation. You cannot do that. I've seen a lot of people attempt that, and again, it's wrong. You're going to lose points. So keep your work organized, keep your work labeled. It takes all the guesswork out of it if you do this little bit of prep work for yourself. Because then you're just plugging it in and then just solving it, and heck, you can have your calculator do a lot of that work for you. So a little bit of organization goes a very, very long way with these problems. So let's take a look at our third example that we have here. So we'll go to our instances. Our third and fourth examples where we start having slightly and then very much weirder stuff going on. So for our third example, we've been given the points 7, 2 and -2, 2. So again, just like our previous examples, we need to label these things as x sub 1, y sub 1, x sub 2, y sub 2. Now for our previous examples, I labeled the first point as x sub 1, y sub 1. I'm going to reverse that for these next 2 examples just to show that you can have them in any order and you'll get the same answer either way. Again, it does not matter which way you would like to label them on the homework or on the test. It's your call. You just need to pick one and then label it that way. So I'm going to do x sub 2, y sub 2, x sub 1, y sub 1. And again, now from here, we have our general equation. And all of the guesswork is going to be taken out of it for us because we did that labeling. So y sub 2 is 2 minus y sub 1, which is 2. X sub 2 is 7 minus y sub 2, which is -2. So again, just plugging things in just as we had it labeled above. And in the line below, I have 2 minus 2 in the numerator spot. That's going to give me 0. I have a double negative showing up in the denominator spot, 7 minus -2. Don't like that. Make that a minus and minus is a plus. Which is going to be 0 over 9. 0 divided by anything, it's just 0. So I have a slope of 0. Which is perfectly fine. We can have this as a slope. I'll give you guys a second to think for yourself or on your own here for a quick 10 seconds or so. What kind of a graph would have a slope of 0? And you can think back to, give you a second here to think on it, but think of the change in y over the change in x. And what kind of a graph would that look like? You don't need to type anything in. Just think for yourself here for a quick couple seconds. I'm seeing a couple people, yeah. This is going to create a horizontal line. So a horizontal line is always going to have a slope of 0. We are, again, looking at our slope in this form. The change in y, am I moving vertically at all? I am not, because I'm not changing my y value. Am I changing my x values at all? Yes, I am. So I'm not changing vertically, I'm changing horizontally. So a slope of 0 denotes a horizontal line. So if we're working with this at all, and we're saying, well, I'm getting m equals 0. Is this really possible? Is this the right answer? It's completely possible. It just means that we're working with a horizontal line is all. We're not working with a sloped line. It's not kind of increasing, nope, horizontal line. Let's work with our last example that we have here, and you guys can probably see where this is going, or you could predict where this is going, but we're going to go through it all the same as if we didn't know. So our fourth example. And we're going to go through it the exact same way that we've done with our previous ones. Let's make that 3 a bit better. Looks a bit off. There we go. Okay, so once again, choosing our x sub 1, y sub 1, and x sub 2, y sub 2. I actually think there's 0.1 and 0.2 if you want to think of it like that also. So that's what we did previously. Let's make sure I'm labeling that correctly. So I'm going to label the first point as x sub 2, y sub 2. Second point is x sub 1, y sub 1. And again, it doesn't matter if you want to label those in the exact opposite order that I'm doing. Does not matter. You'll get the same answer either way. You just need to label it and then move forward with it. So plugging each of these values in, again, make sure you are doing this with parentheses. So y sub 2 is 6. Oops, I'm going to make that a more obvious 6. There we go. Minus y sub 1 over x sub 2, which is 3, minus x sub 1, which is also 3. Got that there. So now simplifying this thing down, we're getting 5 over 0, which means because we cannot divide by 0, we do not get a real answer for this. Our slope is undefined. Because we cannot have division by 0 and find an actual numerical answer to it. Now I'll give you guys a second again. What kind of a graph, what kind of a line is going to have an undefined slope? Giving a quick mirror at our thought process that we had for a previous example. What has a change in y, but no change in x? Give you guys a second or two to think on that. Yeah, exactly. We're going to have a vertical line showing up with this, which means we can change vertically, but we're not changing horizontally. So if we get this, or we get n is undefined, or we get some number divided by 0, this is the slope of all vertical lines, just like you guys were saying. Perfect. So these were the two kind of weird exception cases that show up with our answers. So if you are going through these on the homework or on the test or otherwise, and you're finding, well, hold on, I'm getting 0 divided by something for my slope, or I'm getting something divided by 0 for my slope. Is this even possible? And yes, it absolutely is, because finding the slope of a line, Well, a horizontal line is still a line. A vertical line is also still a line. And they just have a bit more uniquely set up and uniquely defined slopes for themselves. So most lines that we're going to work with are going to have a numerical answer other than 0 and other than undefined. They could be positive, they could be negative, they could be fractions, decimals, whatever. All that's going to determine is a slope that is a line that actually has a slope to it. So they're going to be increasing, decreasing, something to that effect. And these are our two exception cases that are going to be showing up, where we have a vertical line, and then we have a horizontal line. But again, we're just going to be determining that at the very end after we have gone through and solved them the exact same way as we would any other one. We're just interpreting the final answer based on the information that we have been given is all. And this is everything that we have for the slope of a line. So again, the big part that a lot of people do not take into account, do not remember with this, we have 3 ways of writing the slope for ourselves. All of them are perfectly viable. All of them are extremely useful. It just depends on the information we have been given, depends on the scenario that we are working with as to which one we are going to be using for determining the slope of a line. Okay. But this is everything that we have for 4.4. The next page, if you are interested in doing this on your own, does have some group problems, but it's more of a individual practice if you'd like to use those. So finding the slopes of each of these, and then we do have the answers listed down below here if you'd like to check your work for yourself as well. But again, this is everything for 4.4. I'm going to end our recording here and then take any questions that you guys have accordingly.